Hey folks, and welcome to another tutorial. Now in the previous one I showed you how to use a 7-segment display. Link in the description. I advise you to go check that video up, so this one does make sense. Now today we are going to use an encoder, which is this little IC right here, to control 4 displays 7-segment. Okay? Now in most cases you don't want to just hook your pins of the 7-segment display directly to your Arduino or some sort of microcontroller for 2 main reasons. The first one, programming. If you do that, your programming will be much harder. And the second one is the voltage and current limitation of your Arduino. See, an Arduino can only give around 5 volts, 15 milliamps. Some displays need more than that to work. So if you're going to pair 2 or 3 or 4 displays directly to your microcontroller, you will end up frying your Arduino. And yeah, we don't want that to happen. So we need to use some sort of circuit that first can make the programming easier, and it can protect your microcontroller, and it can light up your 7-segment displays. For that we use an encoder, a 7-segment displays encoder. Now before I jump to explaining how it works, I need to make sure that you understand 2 things. First, since we are going to use 4 displays instead of 1, I need to teach you what is a transistor, since we are going to use it right here, and what does BCD means, since we are going to use that to control the IC. Now let's jump to the explanation. Now here, this is our 7-segment displays, and we have 4 displays right here. I'm sorry, I'm bad drawing. So we have from A to G, which are the pins we talked about in the last video, and we have 4 special pins, the one that we need to set to 0 to control or to light up our display, since this is a common cathode. Now all this I covered in the last video. In case you're lost, you can just go watch it. Now since we are going to control it using a microcontroller, I need 2 ways to set these pins to 0 without manually putting it to 0. For that we need some sort of something right here that can connect it to ground at free will. So when I want it to be in ground, it will be in ground. When I don't want to be in ground, it will not be in ground. For that case, we will use a transistor. Now, transistors have many applications, from amplifying to just a lot of applications. But it have one application which is an electronic switch. You see, a transistor have 3 pins. Okay, one of them is base, one of them is collector. So this is base, collector, and emitter. Okay, so we have collector, base, and emitter, and the position of the pins can change depending on the type, PNP and PN, or just the name of the transistor. Now, what you need to know is, like, if you need an electronic switch and you are planning to use a transistor, we have a high potential and a low potential. In most cases, your GND will be your low potential. So you need to hook a collector, your collector pin from the transistor, to the high potential. So this is high potential, and this is how transistor actually looks like. This is MPN type. So you need to put the collector in high potential and the emitter to the low potential, which is the ground. And now we actually need a resistor here to limit the current. Now if I apply a high voltage right here, the transistor will close and the collector will be connected to the emitter. And so if we connect our collector to this pin right here, which is the common cathode of the first display, and the emitter to ground, and we apply a positive voltage, we will set this pin to ground and the LED will light up. And we can actually see the numbers, which is exactly what I did right here. So I have a transistor, I hooked one of the pins, which is the collector, to the common cathode of the display, and the emitter to ground, and when I apply voltage from one of these pins right here, so every pin right here is responsible of one of transistor, which is responsible for putting one of the common cathode of the first display in ground. I hope you understood this. I hope it's clear enough. So this is how an electronic switch works. I hope I you understand stuff. If not, please leave a comment. I'm new to YouTube, so yeah, it sucks. Okay, so now let's say what is a BCD. BCD means binary coded decimal. You see, when you see numbers, let's say you see number 1. This is coded in decimal, but your computer doesn't see it as 1. It actually shows something like 10000 or something like that. Why? Because it is in binary. Now, to convert from decimal to binary, there is a simple way to do it. So we have here 2 to the power of n. So we need to go our way like this. So we have 1, since 2 power of 0 is 1, 2 power of 2 is 2, 2 power of 1 is 2, 2 power of 2 is 4, we have 8, we have 16, and it goes on and on and on depending on the resolution of your converter. Now in this case we're only going to work with from this 4 bit, okay? So let's say I want to see 1. What I'm going to do is I'm going to write 1 here and 0, 0, 0. You see it's 1. I want to see 2. I need to put 0 here, 1 here, 0, 0. You can only write 2, you can only write 1 or 0. So let's say I want to see 3. I need to write it somehow here. So I'm going to write 1, 1, 0, 0. That's 3. If I want to see 9, so 9 is 8 plus 1, right? So we need to put 1 in the 8, 0, 0, and 1 here. So that's 8. Now, how a converter works is it gets info. The numbers you want to show here, you need to send it in binary, something like this, 0 or 1s on 4 bits. And the value that will show in the display is the value corresponded in decimal. Let's say I want to type 0, okay? All I have to do is send zeros to the input of the IC. The IC, it looks like this. So depending on the type of the IC, it can change slightly, but it's all work the same. So we have outputs. This is your outputs that go from A to G. If you notice, it's exactly this segment right here. So this is A, this is G. You need to take your 7-segment display and connect it accordingly. So the A go to the A and so on and so forth, the G to the G. So this is the output. In the input, we have some configuration pins, which you need to check the data sheet to know exactly where to put it, in high or low. And we have input pins, inputs. It goes like this, A, B, C, D. Now, A stands for the lowest bit, which is 1, and D stands for the highest, which is 8. So if I want to send 0 to the microcontroller, actually I want to send 0 from the microcontroller to my 7-segment display, I need to put all these pins to 0. And that's what you need to do. If you want to send 1, you need to send 1, 0, 0, 0, which is equal to A equal 1. And let me change the color. 1 here, 0, 0, 0. And that's how you can send 1 to your 7-segment display. And of course, the common cathode needs to go to ground. So you need to send a plus to your transistor 2 to set this pin low, the common cathode. Now, if I want to send 9, I need to send 1 to A, sorry, and I need to send the pin D to 1. 1D001, which is equivalent to 1001. And that way, I will have an 8 right here. 9. To send 8, you need to send 1000, and that's how you get 8. And this is how you control a 7-segment display using a BCD. And let's put this to the test. Now this is the circuit that I made. I advise you to make something like this if you are going to work with 7-segment displays in the future because it can save you a lot of time. Now what I did was I connected the A to the G of my 7-segment displays to the A of the G of the output of my converter, okay, actually encoder. Now in the input stage I connected A here, B, C and D, and of course I have the base of each transistor connected here. So if now I'm sending zeros here, but I can't see anything because I need to send high voltage to the transistor. See, I'm sending now high voltage to the transistor, which will close, which actually will put this common cathode of this display to ground so I can see the values. Now what if I want to send something else, like I want to see 1 or 2 or 3. Now all I have to do is first of all put this high so I can see my 7-segment displays, and I can send data to A, B, C. In case, let's try the example of 1. All I have to do is send 1, 0, 0, 0, which means A should be 1 or high, and the rest are 0. So I'm going to put A, C. Now if I want to see 2, all I have to do is send 0, 1, 0, 0. This is 0, 1, 0, 0. It's 2.